My name is Osama Saki, and today I'm going to be covering chemical nomenclature. The first thing we're going to start off with is the nomenclature for binary compounds. Binary compounds are simply made up of two elements. So what we're going to do is, our first example is going to be barium oxide. The way we get this name is because it's a binary compound between a metal and a non-metal. So what we do is we literally just take the names of each element and stick them together. So this one is barium, and this would normally be, let's just put the atom ions on it, and this would be oxide. Therefore, this would be barium oxide. Now, this rule generally doesn't apply to covalent compounds, which are nonmetals sharing electrons with other nonmetals. And these can come in a variety of forms. So, for example, we're going to take nitrogen, and oxygen. Keep in mind, these are diatomic oxygen. I spelled that wrong, but we're going to take nitrogen, oxygen, and we're going to make our compound. Now let's see how we go about this. Nitrogen itself is going to be N2 because it's a diatomic molecule, and oxygen, same goes for that. It's also a diatomic gas. But when we combine them together, we're going to get nitrogen monoxide. Now the nomenclature for this, as you can see, is that the first term, if it doesn't have a prefix over here aside from one, we just keep the name. So this would be nitrogen. But from the oxygen side, even though we have just one as our prefix, imaginary prefix you could say, we still say mono. We still add the mono before we write the oxide. Monoxide. Well, that would be repetitive. Monoxide. That's just an X. Let's write here monoxide. The way this goes about is that we have a prefix for each molecule going up to 10. So for 1, it's mono. For 2, it's di. For 3, it's tri. For 4, it's tetra. For 5, it's penta. For 6, we have sexta. Oh, sorry, hexa, excuse me, hexa. For 7, we have hepta. For 8, we have octa. 9, nona. And 10, deca. The last thing I want to cover for today is how to name polyatomic compounds. So let's, for example, let's take calcium carbonate. We know calcium. I'm just going to change color here. Calcium is Ca, calcium. And let's take a polyatomic ion. Well, let me make that an ion. Carbonate. And we know that has the formula CO3 2-. So carbonate. And just like with the binary compounds, we're literally just going to take the name and bring it down. So this is going to be the compound calcium carbonate. So far we've learned that only covalent compounds need special prefixes. However, if you have substances that have multiple charges in their ion form, let's take for example iron. So iron, Fe, oxide, or iron oxide. So how would you decipher the one, which one it is? Because in this case, the charge has a 2+ charge, but in this case it has a 3+ charge. So the way we go about showing the difference is that we would write, when we write out the name, we would write iron, and then we write the charge in Roman numerals, iron 3 oxide. Whereas over here, we would write iron 2 oxide. So the Roman numerals are very important, especially for the transition metals, because many of them can take different ions, form different ions. Some of them form 1+ ions, 2+ ions, 3+ ions, 4+ ions. Some of them might even pick 2 or 3 of them. Iron, as you can see, already took 2 and 3+. So it's very important to have those Roman numerals when we're dealing with transition metals that we know have different ion variations. And we also are going to do that same thing not only for binary compounds but also for polyatomic compounds. So even if this was iron 3 carbonate, we would still write it out as iron 3 carbonate. Alright, that's all I have time for. I hope this helps. Thank you.